Welcome to EE252 Electronic Devices and Circuits. Today we are going to talk about BJT Hybrid Pi model. This is a simplified model of the H parameter model which we discussed earlier, and in the last lecture we discussed some techniques or analysis methods to find parameters such as input impedance, output impedance, voltage gain and current gain for a BJT amplifier. Now today we are going to talk about another model which is actually a simplified model of the H parameter model. So this is used for common emitter configuration because we can remember that the output for the H parameter model, HIE or rather HRE, the reverse voltage gain, was rather high, rather low, something like 10 to the minus 4, right? 2.4 times 10 to the minus 4 or something. So therefore this HRE value typically is very small, very small, in the range of 10 to the minus 4. So therefore we can neglect it and assume it to be 0. The HRE can be assumed 0. Okay, with this assumption we can actually simplify the previous model of having 4 parameters into 3 parameters, and if we use a different notation to indicate this new model. With earlier we called the input impedance HIA, but now we call it R pi. R pi is basically the HIE, and also we use R naught to represent the output impedance, which was initially represented by 1 over HOE, right? It is the output admittance that we had. HOE was the output admittance, but we are going to use it as output impedance now. The other parameter that we had was HIE, which we are going to call beta now. HFE, I'm sorry. The HFE is going to be called beta. So if you draw the new model with these, basically without HRE we will have only 3 parameters. If you draw this circuit, let's start with the original H parameter model. The H parameter model consisted of the HIE, so let me draw it here. So we had HIE, these are terminals, base, collector and emitter. We had HIE, HRE times the output voltage, that is VCE, capital VCE, that is the output voltage, and the current here is the input current, capital I simple V, that is the phasor notation. So these are the phasor values, the RMS values, and the current source HFV times IB, and output admittance HOE. So this was what we started with, and the output current is IC. We can convert this model into our new model with just 3 parameters by eliminating this HRE term. So HRE is equal to 0, so that we can get rid of this voltage source, dependent voltage source. HIE is now R pi. HOE, instead of 1 over HOE we put 1 R out, and instead of HFE we use beta. So the new circuit we have like this. Okay, so we have the base collector emitter, the dependent current source, the output impedance R out, the dependent current source beta times IB. IB is the input current, and instead of HIE I have R pi, right? So this is basically what we have, and the currents IB is there, and the output current is IC, and the current in the emitter is IE, which is the addition of IB plus IC. Okay, so we have so now we can improve this model a little bit by replacing this current dependent current source IB. So it's the current through this the current source is IB times beta. Instead of it being a current dependent current source, we replace it with a voltage controlled current source. So what we have here is current controlled current source, and we are going to replace it with a voltage controlled current source. Okay, so let me draw it again. What you have here is so you have the same thing, the input impedance, the R pi, the current dependent current source, and the R out, this is the B base collector and emitter, and you have the R pi, R out, and here beta times, instead of I'm sorry, not beta, let's use GM times the input voltage, that is VBE, simple capital V, simple BE. So that is the input voltage between base and emitter that you use as the so the and the input current is IB, output current still IC, and output current will be IE. So this is the input voltage VBE, capital V, simple BE. So it depends on that. Okay, so this is a little bit different because earlier we had a current controlled current source, now we have a voltage controlled current source. Other than that, everything is the same, but we have to have all the quantities as the same. Okay, so therefore initial current through this current source was HFE times IB, which, but we know IB is the current through the R pi. R pi initially was HIE. If you go back in the original circuit, you have HIE and HRE is now 0, so therefore only the HIE is there between emitter and base. So we can say the current should be equal to IB is equal to VBE divided by the input impedance HIE. Okay, so we have that. Let's call this GM times VBE, where GM is HFE divided by HIE. Okay, so we call this the transconductance. We call this the transfer conductance, and sometimes instead of a conductance we look at it as a resistance. Okay, so 1 over conductance, we call this RE. RE is equal to 1 over GM, which is HIE divided by HFE. So this is none other than R pi divided by beta, because R pi is HIE and HFE is beta. So okay, so if I replace with new notation, we have it R pi divided by beta. Okay, so with this now what this is actually the emitter resistance. Re is the emitter resistance. So now what we initially had was a resistance in the input side, but now we are going to call this emitter resistance, and sometimes this is also called the emitter spread resistance. This will be so we can, instead of using the resistance in the base side, you can move it to emitter side, but now when you are doing it, we have to divide the R pi by beta, because you know the current through that branch is bigger, so you need to have the same voltage drop between base and emitter. To maintain that, we uh, divide R pi by, in fact it should be beta plus 1, but beta is big, so therefore we can actually have that. So initially this was at R pi was at the base side, now we are moving it to emitter side. So this Re is basically R pi divided by beta, but we have to make sure that in both situations we have the same parameters. The voltages and currents flowing into and across these terminals have to be the same. So we need to have so this should be not beta, this if we are using beta, it should be beta times IB. If not, we have to use GM, I'm sorry, GM times VB, IC, IB and IE. IE is basically IC plus IB. Now the voltages, the voltage between B and E should be the same. Now R pi is no longer there, only the Re is there. So initial voltage across base to emitter was IB times HIE. Okay, so if you take this as a black box, we have three terminals: base, collector and emitter. So no matter whether you have what model, you still have to have the same IB, same IC and same IE, and same voltages between emitter and the base, VBE, and emitter and the collector VCE. So these need to be the same. So if you write the voltage VBE in the previous case, it should be equal to IB times, so IE is equal to IB plus IC. Now the new current is IE, so this is 1 plus beta times IB, which is actually very close to IB times beta when beta is big, right? So VBE is equal to IB times R pi, which is also equal to, so you can have a look at it, R pi when it was in the base side, the current through it was IB. So that's why it's the VBE. There was nothing else in the emitter side. Okay, so now this is IB we can write as IB is basically IE divide we can write as R pi times, R pi is basically the HIE, and IB is roughly equal to IE divided by beta. It's actually IE divided by 1 plus beta, but when beta is much bigger, like some 50 or 100, which is the typical value, in which case whether it is you divide by 51 or 50, it doesn't make much of a difference. So therefore instead of IB we can write IE divided by beta. So this is what we have. So now we can say R pi, which is so this voltage should be the same as Re times IE. the new voltage across base and emitter. So therefore we can say Re should be equal to R pi over beta, right? R pi over beta is equal to Re. The emitter resistance you can find in terms of HIE by dividing by HFE or beta. Okay, so that will I can express my new parameters in terms of my old parameters now in this new H parameter model. Now it is also possible to uh, obtain new further simplifications for this. We can further simplify this if the output impedance R out is much bigger than the load resistor. If the load resistance, let's say, is 1K and my output impedance R out is like 40K or something, or greater than 10K, my output by assuming, because now we have two resistors in parallel, RO and RL. If RO is much bigger than RL, then we can assume RL is the only one in that pair, and the effect of RO will be very small. So therefore, as a rule of thumb, we use a factor of 10. So in such case, we can ignore that value as well, so that we have so the error introduced due to this is much less. It's something like less than 10%, which is not really bad, because what we are trying to do is we compromise accuracy for the ease of computation, and what we are going to get is an approximate solution which is sufficient in most of the cases, and some of the cases. And also this is not as bad as it looks, because the parameters, H parameter values, also change from their nominal value. Okay, so this approximation is not as bad as it looks. So with this new assumptions, we can get try to obtain the new circuit. So we have the new current source. You can use it as a voltage controlled or current controlled, but we don't have the output current, output resistance R out. Now we assume it is 0. Okay, so we have the base collector emitter, we have the Re, basically R is equal to R pi divided by beta, and beta times IB, or GM times VBE, simple V, capital V, simple B, GM times VBE, IB, IC, and IE. Okay, so this is my new circuit. New circuit is like that. And if I want, in some cases, it's easier to work with the resistor in the base side rather than the emitter side, so we can have it the other way as well. So if I draw that, it looks like it's the same thing, but we just click it's equivalent. So we move the resistor to the base side, so you have R pi, and we have R, so this is Re times beta. This is because Re is equal to R pi divided by beta, and we have the other parameters, the beta times IB and IB, IC, and IE. So these basically this is what we have. The voltage input VBE is between these two, both these cases the same value. Output is VCE between emitter and collector. So this is basically what you have for your circuit. Okay, so this basically ends today's lecture. Thank you.